Most gardeners never realize that tossing raw charcoal into garden beds can quietly rob plants of nitrogen and minerals during the first weeks after application. Fresh biochar is basically a hollow carbon skeleton filled with empty microscopic chambers. Those pores act like thousands of tiny sponges desperately pulling nutrients from surrounding soil. Instead of feeding plants right away, the charcoal behaves like an empty battery trying to charge itself. Until those internal cavities are filled, the soil pays the price. Raw milk solves that problem in a surprisingly elegant way. Milk carries a dense package of calcium, proteins, amino acids, fats, sugars, and trace minerals that plants and soil microbes both depend on. When charcoal is soaked in this living liquid, those nutrients seep deep into every pore and tunnel within the carbon structure. Instead of remaining hollow, the charcoal becomes saturated with a rich biological broth. Calcium from the milk becomes especially valuable in the garden. Plants use calcium to strengthen cell walls, regulate nutrient transport, and improve overall structural resilience. When that mineral is stored inside biochar, it remains protected from rapid leaching. At the same time, the natural sugars in milk feed beneficial microbes that begin colonizing the char's surfaces. These microbes convert proteins and sugars into plant-available nutrients while establishing stable microhabitats within the carbon matrix. In nature, this charging process happens slowly through compost, manure, and rainfall over months or even years. Soaking biochar in milk accelerates that process dramatically. Within a few days, those empty carbon skeletons become microscopic batteries packed with nutrients and living organisms ready to support plant growth. Start with clean crushed biochar or untreated lump charcoal broken into small pieces. Avoid briquettes or anything containing chemical additives. Smaller pieces expose more surface area, allowing the milk to penetrate every internal chamber. Place the charcoal in a bucket or container and pour raw milk over it until the pieces are fully submerged. A practical working ratio is roughly 1 part charcoal to 1 part milk. This ensures there is enough liquid to fill every pore without leaving dry pockets inside the char. Allow the mixture to soak for 2 to 3 days. During this time, trapped air bubbles slowly escape while the milk replaces them deep within the structure. Keep the container loosely covered and stored in a shaded area. The goal is to allow microbial activity without encouraging spoilage odors. Gentle fermentation is normal and actually beneficial, as it helps break down milk compounds into forms microbes and plants can easily use. Once charged, the charcoal becomes a living nutrient reservoir. Mix the soaked biochar into compost piles or directly into garden beds where future roots will grow. Many gardeners work it into the top several inches of soil or concentrate it near planting rows so crops can access the stored nutrients quickly. Instead of nutrients washing away during heavy rains, calcium, proteins, and microbial life remain trapped within the char's porous framework. Roots gradually tap those reserves while microbes continue cycling nutrients around them. Gardeners often notice greener leaves, stronger stems, and soil that holds moisture far longer than before. A single application of charged biochar can keep working for years because the carbon structure resists decomposition. Over time, more microbes move into the tiny chambers, building complex soil ecosystems that recycle nutrients naturally. The soil gradually becomes darker, softer, and more resilient to drought or heavy rain. Instead of depending on constant fertilizer inputs, gardeners begin developing a self-sustaining soil system powered by carbon and microbial life. What began as simple charcoal evolves into a long-term fertility engine beneath the surface. Subscribe to Timeless Humus Path for more timeless soil revival wisdom delivered weekly. And pass this video along to anyone growing food or restoring tired land. The more we rebuild living soil, the more abundance we create for gardens, farms, and future generations.